So real quick, because we can determine intercepts from the graphing calculator as well. So we had 3 functions in there. So the first function is the cost function, which is 20x plus 100,000. Then we have 45x, which is the revenue. And then the last one, we have 25x and minus 100,000. One of the reasons why I wanted to do this is because we have to adjust the viewing window. So what do I see? I see from 0 on the x-axis, from 0 to, let's say, 150,000. I don't have to go beyond that. I mean, actually, I shouldn't even go beyond 10,000, to be honest. Let's just do that. 0 to 10,000, okay? Or even more, 0 to 100,000, that's fine. But what about the y-axis? Between 0 and 500,000. So the scale will be 100,000 for the y-axis, and it will be maybe 20,000 or 30,000 or 50,000 for the x-axis. This is extremely important to be able to adjust the viewing window. So let's go to window. So x minimum 0, x maximum, let's say, we don't have to, but let's put 150,000. I'm going to put a scale of 50,000. Y minimum 0. Y maximum definitely 500,000. And with a scale of 100,000. Okay? So now when I hit graph, I see the total cost. I see the revenue starting here, and I see the profit. Not a very good graph because I have too much on the x-axis, so I'm going to cut off the x-axis. I'm going to say that the x-axis, x maximum is 10,000 with a scale of 2,000. Okay, let's see what happens now. This should be a better graph. So here's the total cost. Here is the revenue. And since I have 10,000, somewhere here, the profit. So you see when the two revenue and cost are equal, the profit is 0. Okay, so I think we had enough of this. So any questions for me? The last thing in R.5 in prerequisites or review so I'm on page 7. So R.5 last we are looking at still functions and graphs, but nonlinear functions and models. So I'm going to say nonlinear functions, although I'm not going to show too many graphs here, and models. I prefer to look at models. Okay. On page 65, we are given a supply function and demand function. Okay, let's talk about supply and demand. Functions. Because we need this for later. Okay. Quantity, price. The supply function is normally denoted by S, and in your book anyway. So, and the demand function is demand, D. Supply demand. Let's analyze just common sense here. Let's use common sense and say this. Let me see if I started my second video. Yes, I did. Okay. Good. So if the price, let's talk about the demand. Let's say it's a product, a vehicle, whatever you want to think about. So let's talk about the demand. If the price goes up, what do you think will happen to the demand? It goes down. Yes, because less and less people can afford a $200,000 car. So as the price increases, the demand will decrease. So I'm not saying that the demand will always be a linear function, right? But it will definitely decrease. It can be a rational function, it can be a linear function, but definitely the demand will be decreasing. As price goes up, the demand will decrease. Now, what about the supply? Now we're talking about from the manufacturing point of view. What do you think the producers will prefer? To sell a product that costs $1 or more products that cost $1,500? $1,500. Right. So what do you think will happen with the demand, with the supply? Will it be an increasing function or a decreasing function? Again, I'm not saying that it will only be linear. It can be it will be definitely increasing. So the supply function will always be increasing. The price, as the price increases, they want to manufacture more and sell more. Okay. What do you think this point will represent? When the supply equals the demand. This point. It's called the... Exactly. Awesome. So E this is the equilibrium point when everybody's happy. At this particular price, P, on the y-axis, the supply equals the demand. And everyone is happy, meaning the consumers are happy that this is the price and they buy. The supplier, the manufacturing units are happy because that's the price and they're willing to manufacture at that price. So that's, everyone is happy. So I'm choosing a problem, let's say 92 on page 65, and in which we're asked, we are given the demand, okay? So the demand function, bless you, is this, and the supply function is x squared plus 2x plus 6. And they're asking us to find the equilibrium point. Find the equilibrium point for each pair of demand and supply functions. Try to get used to the fact that their book also denotes both of them by Q, which is fine. So another way is Q and Q, like Y and Y, right? Y, the function is this, and another function is this. So we're asked to find the equilibrium point. Because we're asked to find the equilibrium point, we will have to determine the x and the y. Good, coordinates. Yes, I still have time. So what do you think we should do? Let me show you the graphs. So this is the graph of one function, and this is the graph of the other. This is the demand, this is the supply. Okay, so what do I need to do? Yes, please, Maddie? Of course. I have to write x minus 4 squared equals x squared plus 2x plus 6. Awesome. What type of equation is this? Excellent. If it's a quadratic equation, how many solutions do I expect? Two. Well, I hope it's only one, because they can meet in 2 points. Okay, very good. The left-hand side, please. We discussed this. Well, no, not anymore. We discussed it on the first day of class. Will you get full credit if you foiled? Yes. Do I want you to foil? No. Sorry. Yes. How many terms do we have to write when we square a binomial? How many? Very good. And they are?
Squared minus 8x plus 16.
Excellent. Very good. First term squared minus 2 times the first times the second plus the second term squared. And as I was hoping, these two go away and the equation collapses into a linear equation. That was my hope. I move 2x to this side and I move 16 to the other. When I move 2x to the left-hand side, what do I get? Negative? Very good. And when I move 16 to the other side, I get? Good. So then the price is $1 per unit. But we are asked to find the equilibrium point. So I found the x coordinate. Now how do I find the y coordinate? So the two functions meet in this point. How do I find the y coordinate of this point?
Do we plug in the x coordinate?
In any of the two functions, because they have to be the same. In any of the two functions. So the easiest one is to plug into x minus 4. When I plug in 1, 1 minus 4 is? Negative 3 squared.
9.
So the equilibrium point where the demand and supply are equal and everyone is happy is when the price per unit is 1 and we sell 9. Of course, 9 could be 9 million. 9 could be 9,000 or 90,000. Who knows? Okay, but that's the equilibrium point. Awesome. Okay, I know I only have about roughly 10 minutes, but I would like to start chapter 1. Just to give you at least the idea. In chapter 1, we talk about differentiation. At the end of chapter 1, when we go through all 8 sections in chapter 1, we will schedule our first test. We will review and schedule our first test. Okay, so chapter 1. Please do not forget to finish all your homework as soon as possible and bring any questions to class from the review. So R.1 through R.5 is done. So I'm hoping that you will work on all the assignments as soon as possible and bring a list of questions. Okay, please, on Thursday, please. Please. Okay, chapter 1, differentiation. Differentiation. So the first step, before we get to differentiation, the first step is section 1.1, in which we're going to look at limits. Let me refresh our memory about that P point and that Q point. And we said that this was the slope, this was the line connecting, or the secant line connecting P and Q. And at some point we said that this was x and this was x plus h. And we wrote that if I bring Q closer and closer to P, it really means that h gets closer and closer to what? Very good, awesome. And then we also said that the slope of the line PQ will get closer and closer to the slope of the tangent line at P. This is what we wrote last week sometime. Well, this is not the notation we will be using moving forward. We're going to use an operator called LIM, limit. Do we know other operators in math? Of course. We know the square root. The square root is an operator. Is there another? Yes, natural log, ln. ln is an operator, and so on and so forth. So now we're talking about limit. What does this mean, and what is the notation? Okay. Let's look at this very simple function. Can anyone tell me what, or tell us what type of function am I graphing here? Linear function. It's a linear function. I'm going to make up a point here. I'm going to say that this is 2. And this is 1. Okay, so follow me for a moment. If x gets closer and closer to 2 from either side simultaneously, x gets closer and closer to 2 from either side simultaneously, what can you say about the function values when that happens? What do the function values do? Get closer and closer to 1. Do you agree with that? One more time. As x gets closer and closer to 2, the function values get closer and closer to this number, to 1. How do we write that? We write it as LIM. I'm going to call the function f of x. Limit of f of x as x approaches 2 from either side. I'm going to put this in writing also. Equals, again, how much? 1. So this is how we read this. Limit of f of x when x approaches 2 from either side is 1. I know it's a mouthful. So limit of f of x as x approaches 2 from either side is 1. I would like to look at one example. I know I only have 3 more minutes. I will not hold you over. Can anyone refresh our memory on what this is? And here comes the function. So this is the function. Can anyone tell us what this is?
Line of symmetry.
Say it again.
Line of symmetry.
No.
Asymptote.
Yes. Vertical. Thank you, Maddie. The function is undefined when x equals 2. Therefore, that is a vertical asymptote, but only if one of the two sides goes to at least 1, goes to infinity, or negative infinity, or like this. Okay, so now I would like you to say how much is the limit as x approaches 2. I put a positive, it looks like a power, x approaches 2, positive, f of x, which means the right hand limit. I'm only interested when x approaches from the right. Where the function values go? Where do they go? To infinity. Note, a limit exists only if it is a number, comma, not infinity. Infinity is not a number, infinity is a symbol. So in this case, the limit does not exist, but I have to write infinity. Final graph, and I'll stop. I want to graph same thing, same vertical asymptote, But here is the graph now. So the limit as x approaches 2 from the left of f of x, limit as x approaches 2 from the right of f of x, and then I would like you to give me the limit of f of x as x approaches 2 from either side. So in my graph, I'll stop right here after these three answers. So the limit from the left, please. Do you see that? As x approaches 2 from the left with values that are smaller, that's a symbol with values that are smaller, the answer is infinity. The limit as x approaches 2 from the right-hand side, the answer is? Very good. What do you think the answer is right now? Although these do not exist, I have to write infinity and negative infinity. So what is the final answer for either side? Exactly. It does not exist. I'll stop.